Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which is helpful for the international entrance or any competitive exam if you are preparing for national level JEE advanced and JEE mains examination. That will be helpful for IIT and NIT entrance examination from the intermediate level. NEET chemistry for medical entrance examination from the intermediate. Telangana and Andhra Pradesh MCET examination for the engineering stream, engineering entrance examination. In addition, if any government examination you are preparing for, in that common paper general studies will be there. In that general science in the commonly available content, where the kind of session what we are discussing will be very much fetching for you. Let's enter into our today's session. Here is the compound. Explain the name of the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, this is the compound. If you see, it is a bicyclic system with the two nitrogen heteroatoms. It is somewhat complicated to give the name, so that IUPAC gave certain guidelines in order to name the given compound. Let's see how can we name this. Being it is the bicyclic compound, we have to go for bicyclic system, bicyclo to be mentioned in front. Okay, and commonly the compound is said to be DAPCO. DAPCO is the kind of catalyst which is used in the organic chemistry for nucleophilic substitution reactions. DAPCO is the kind of catalyst used in the nucleophilic reaction, so that it is important, synthetically important reagent in the research field. Okay. So for this compound, how can we assign the name? That is the task for us, right? So here, first of all, we have to mention heteroatoms whichever present in this. Heteroatoms are nitrogens, and two nitrogens are located on the first carbon and fourth carbon. So that, let me say 1,4 diaza. So nitrogen is mentioned as a aza. If sulfur is there, thia. If oxygen is there, oxa. This is the way we have to pronounce. Okay, being two nitrogens are in 1,4 positions, 1,4 diaza is a prefix over there, and two cyclic rings are present. So it is mentioned as a bicyclo. After mentioning bicyclo, just now we discussed about the bicyclic system. How can we give its a name, right? In order to give the name, in one side, how many atoms are there in between nitrogen? Here one carbon, here one carbon. Each corner indicates carbon atom, no? So that, let me say, this is the corner carbon, this is another cornered carbon. So two carbons, so that two mentioned for this side. Move on to right side. Right side also, if you see in between two nitrogens, here one carbon, here one carbon. So that another two is mentioned over there. So in between these two nitrogen, if you see, another puckered type of ring is there, a line is there where you can see two nitrogen atoms, two carbon atoms again. So that here another two indicated. The starting two for left side, the second for right side, the third is for central carbon, carbon. This is the way 2, 2, 2. After mentioning this one, we have to go for entire number of atoms. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Total number of atoms present in the compound are 8. 8 denotes octane. Being entire compound is saturated, no double bond or triple bond, so that octane is the suffix provided over here. DAPCO is IUPAC. Name is given by 1,4 diaza. 1,4 diaza bicyclo 2,2,2 octane. This is the way we have to give the name for the compound. And the DAPCO is a very essential catalyst in the synthetic organic chemistry. And here is the example which facilitated by the DAPCO catalyst, where you can say aldehyde compound, another alpha beta unsaturated carbonyl compound was taken when both get fused in the presence of DAPCO. DAPCO is the nucleophilic catalyst which will increase the rate of this kind of reactions. So that naming of this compound is given as 1,4 diaza bicyclo 2,2,2 octane. For compound number 1, 1,4 diaza 2,2,2 octane is the right name as per the IUPAC protocol. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. A compound with the formula XO2 has a relative formula mass of 64. What is X? Here, unknown compound is given to you. Its formula mass is provided. Half of the compound structure is revealed by oxygen, so that it is very simple to identify what the leftover term we have in this formula, right? So X to be identified, either it may be cadmium, copper, gadolinium, sulfur. From these we have to predict. In order to get that one, first of all we have to calculate what oxygen atomic mass and O2, entire O2 molecular weight. For that, XO2, within the data they provided, its molecular weight is 64. Whenever XO2 is 64, oxygen term we can exclude. Oxygen, individual oxygen contributes 16 atomic weight. How many are there? 2 are there. 16 multiplied with 2, 32. 64 you can subtract 32, and the leftover will be 32 only. 32 is the unknown element whichever present here. That 34 atomic mass is accorded for sulfur. That's why here SO2, if the compound for XO2, then molecular weight, if you calculate molecular weight for SO2, that will be 64 only, so that there is a kind of relation. So X can be identified like a sulfur. It is very simple to identify. So oxygen atomic weight is known to you, and we have to multiply twice because it is taken as a twice. So molecular weight is given to you. From that molecular weight, known term we need to subtract, and whatever leftover is there, that is the atomic weight of unknown element whichever present. That unknown element atomic mass is 32, so that atomic number is 16. 16 atomic number element in the periodic table is sulfur. So that sulfur if substituted, again it is exactly mapping with the molecular weight 64, so that X is regarded as a sulfur. For question number 2, option number D will be the correct answer. Move on to question number 3. This question is collected from JEE Advanced 2020 question paper, paper 1 question it will be. With respect to hypochlorite ion is given, and chlorate ion is given, perchlorate ion is given. All these are the oxyacid ions of chlorine. Hypochlorite is the oxyacid anion, chlorate is the oxyacid anion, perchlorate is also the oxyacid anion of chlorine. Choose the correct statements. Which are correct from these 4 options? Among all, multiple options are correct like A, B and D. Let's see. Hypochlorite ion is the strongest conjugate base. Here, conjugate acid base, how can we predict them? Any acid, it's a conjugate base, both are differed by only one hydrogen, one H plus difference is there, both are said to be conjugate acid base. Okay, so and one more fundamental we need to know is, if the starting material acid is weak, its a conjugate base will become strong. If starting material acid is strong, then its a conjugate base becomes weak. So that is the kind of relation you can find. One hydrogen difference makes the entire properties completely reciprocated, right? So here hypochlorite ion is the strongest conjugate base. This is correct only. And second is, molecular shape of only chlorate ion is influenced by the lone pair of electrons. In chlorate only lone pair of electrons matters for its geometry. Hypochlorite and chlorate ions disproportionate to give identical set of ions. Both are disproportionating giving same ions. They are saying it is not correct actually. The hypochlorite ion oxidizes the sulfite ion. So hypochlorite oxidizes sulfite ion is the correct answer only. We have to give the explanation for all these options, which are correct, which are wrong, why they are correct, why they are wrong. Let's see. Since HOCl is called what? Oxo acid of chlorine, and it is called what? Hypochlorous acid. HOCl is called hypochlorous acid. Whenever hypochlorous acid is considered, it is the weakest oxo acid of chlorine. It is the weakest acid. Whenever H plus removed, it is converted into ClO minus. In between HOCl, ClO minus, what you find? The difference is only H plus. That's why both are conjugate acid base, right? So being HOCl is weak, its a conjugate base will become stronger. Whatever in the option 1 they mentioned, exactly correct. Move on to B. In B, hypochlorite ion is there. Hypochlorite ion is having chlorine with a 6 lone pair of electrons. Non-bonding electrons will be there. Oxygen with the negative sign. And in case of chlorate ion, you can find a Cl, double bond O, O minus. And lone pair of electrons will be there. In case of perchlorate, we have Cl, double bond O, O minus. Here is another possibility. The question they are saying is the molecular shape of only chlorate ion is influenced by the lone pair of electrons. Okay, so here lone pair of electrons are present. This is not influencing. Hypochlorite being it is the diatomic only, so that it will not influenced by this one. We can't make it a bent, we can't make it a triangle, we can't make it into planar like that, so that the lone pair of electrons is not a matter of its geometry in case of hypochlorite. If you go with chlorate, in chlorate what happens, there are multiple phenomenons matters over here. Here bond pair repulsions occurs, lone pair bond pair repulsions occurs, lone pair negative charge repulsions also occurs. That's why it's a geometry conveniently affected by the lone pair occupation. Lone pair must be occupied in the particular region. Then only you have to go for the least energy, more stability. Lone pair matters for its stability and its geometry as well. That's why in the chloride, in case of ClO minus, there is no other provision. Instead of this linear, there is no other provision. But in case of this chlorate, ClO3 minus is called chlorate ion, no? Where you can find a lone pair, bond pair, negative sign. In order to balance all these, a particular location of these lone pair of electrons are very important, so that it's a geometry particularly directed by the lone pair electrons located on the chlorine, so that chlorate influenced by lone pair of electrons. It's a geometry influenced by chlorate ion. And move on to this perchlorate. There is no question of lone pair because chlorine completely participated in bonding. No bank balance on this. No lone pair of electrons upon this one. So that perchlorate ion is not having any kind of lone pair. So there is no question of lone pair of electrons related with its geometry. So only what they are saying, in chlorate only lone pair of electrons matters for its geometry. That's correct. Move on to C. Hypochlorite and chlorate ions disproportionate to give the identical set of ions. If you go with hypochlorate, hypochlorate stands for what? ClO minus. Disproportionation stands for what? A single compound will participate in the oxidation and the reduction simultaneously. One of the compound is oxidized one, another compound is reduced one. So both will be formed from the same starting material. Then we can say it is the disproportionation reaction. Disproportionation of ClO minus gives rise to Cl minus, ClO3 minus. Cl minus is negatively charged. ClO3 minus, here you can notice ClO3 minus what charge you can see here, plus 6 will be there, plus 6 minus 1, so that plus 5 charge will be there. Here minus 1 plus 5, so that it is the kind of disproportionation only. One chlorine is having plus minus 1 charge, another chlorine is having plus 5 charge. One is oxidized, one is reduced. This is a disproportionation only. If you go with ClO3 minus, ClO3 minus is called what? Chlorate. Whenever chlorate disproportionated, you can find one is Cl minus, another is ClO4 minus. Here, one of the chlorine is in minus 1, another chlorine is in plus 7. Plus 7. So that, can you find same products by the disproportionation? No. Here you can find Cl common, but ClO3 minus, ClO4 minus different. So that we can't say option C is correct. So both are not identical, rather both are different. Move on to option D. The hypochlorite ion oxidizes sulfite ion. Okay, hypochlorite stands for ClO minus. This ClO minus having natural tendency to convert sulfite ion into sulfate ion. What it did? CO3 minus 2. SO3 minus 2 is converted into SO4 minus 2. That means one of the oxygen added, no? So that we can say it is the oxidizing agent. It is facilitating the oxidation process. So that oxidizing agent. So that oxidation of sulfide to sulfate is possible. So option D is the correct only. For question number 3, 1 is correct, 2 is correct, 4 is also correct. A, B, D are the correct options. This is the question purely given from inorganic chemistry where we can go for the halogen family elements. Entire question purely based on halogen family elements only. Okay, so question 3 completed. Move on to question number 4. Question number 4 is collected from JEE Advanced 2020 question paper held on 27th of September 2020. So this is official paper 1 of chemistry we collected. Consider the reaction where A gives rise to B and B further converted into A. It is the kind of reversible reaction. And the reaction is carried at 1000 Kelvin, extremely high temperature we are maintaining. At a time t, temperature of the system is increased to 2000 Kelvin. 1000 to 2000, we doubled the temperature and the system was allowed to reach the equilibrium. Okay, so whenever temperature got doubled and they are acquiring equilibrium. Throughout this experiment, the partial pressure of A was maintained as 1 bar. This is nothing but isobaric reaction. Isobaric reaction stands for the entire reaction where pressure kept constant. The reaction is said to be isobaric in nature. Isothermal means a temperature constant. Isochoric means volume constant. But here we kept a pressure constant so that it is called isobaric reaction, right? Given below that, the plot of partial pressure of B with the time. What is the ratio of standard Gibbs energy of the reaction 1000 Kelvin to that of 2000 Kelvin? Here the graph is plotted between, this is called water T and this is called water partial pressure of B in bars. T for what? Time. Time was taken on the X coordinate, partial pressure was taken in the Y coordinate, being entire process carried at 1 baric temperature, so that we are not supposed to change the pressure conditions. Only time get varied. Okay, so time get varied, pressure will not be changed. This is a kind of graphical representation of the problem. Okay, they're asking for consider the reaction temperature of the system increased, then what is the ratio of standard Gibbs free energies? Gibbs free energy at 1000 Kelvin, Gibbs free energy at 2000 Kelvin. That ratio we have to consider. That ratio is given as 0.25. Being it is a ratio, no units mentioned over there, right? 0.25 will be the correct answer. Let's see how can we achieve this answer. In order to get that one, so the formula for Gibbs free energy is delta G naught is equal to minus RT ln Kp, right? So delta indicated for the large changes, small dou indicated for the partial changes. Here, so this delta indicates it gives a free energy change is larger in the magnitude, and here one dot is indicated. This dot is meant for what? Standard conditions. It is the standardized Gibbs free energy change. Okay, so if you are maintaining temperature, pressure, and volume such terms and at a standard conditions, then we have to put the dot over there which indicates the standard condition. So let me mention standard free energy change formula is equal to negative RT ln Kp. Okay, P for what? Pressure constant. Okay, so here at the equilibrium, this is the equation. So at the equilibrium, this equation was drawn. And they mentioned for different temperatures, no? T1 temperature is there, 1000 Kelvin, T2 temperature, 2000 Kelvin is there. That's why. So for T1 temperature, delta G1 naught we have to consider, where negative RT1 ln Kp1 it will be. This is for temperature 1, gives a free energy 1. And for temperature 2, that means a 2000 Kelvin temperature, its gives a free energy will become delta G2 naught is equal to negative RT2 ln Kp2. This is the formula for second temperature. This is the formula for first temperature. Let's take the ratio of both. Delta G1 naught by delta G2 naught is equal to T1 by T2, because R got compensated. Both are gas constants, similar magnitude, right? So that we can cancel out. T1 by T2. Negative, negative signs also compensated. Both are negative, negative. In the numerator, denominator, both the values got cancelled. T1 by T2 into ln Kp1 by ln Kp2, right? So this is the concise equation for the ratio of delta G1 naught by delta G2 naught. Temperature 1 is 1000, temperature 2 is 2000 Kelvin. ln Kp1, ln Kp1 ln Kp1 is given as 10. Here, if you see the graphical representation, partial pressure will be started from 10, and in final pressure is taken as 100. So from the graph, the data is provided. So here, initial P1 pressure is taken as 10, final P2 pressure is taken as 100. So that let's put ln 10 by ln 100. Okay, 1000 by 2000, zeros get cancelled, 1 by 2 left over. Log 10 stands for 1 and log 100 stands for what? 2. So that 1 by 2 it will be. Log 10 is 1 and log 100 is 2. So that 1 by 2. 1 by 2 into 1 by 2. That will be 1 by 4. 1 by 4 you can simply write in the decimal points 0 0.25. 0 0.25 is mentioned as the answer. This is the kind of question came from the chemistry with the mathematical blend. So if we are having some extent of mathematical fundamentals, then only we can answer such kind of questions. And it is the part of thermodynamics. For question number 4, 0 0.25 will be the correct answer. Move on to question number 5. Read the following two statements, A and B, relate them. A and B statements are there. We need to relate these two statements as well. Okay. Again, it is the kind of question came from delta G Nernst equation, so that we can say it is the electrochemistry. It is the part of electrochemistry, physical chemistry question. For all the spontaneous chemical process, delta G is negative at the constant temperature and pressure. Okay. When spontaneous process considered, spontaneous means the reaction which is feasible without any involvement of external conditions itself, it used to do that. Spontaneity. Let me take water. Always water tends to move from top to bottom, no? So that is called its spontaneity. Likewise, chemical reactions, some also spontaneous in nature without any external force. They will be performed themselves. Those are called spontaneous reaction. In that spontaneous reaction, delta G is nothing but internal free energy change must be negative. This is the condition for a spontaneous reaction, and we need to maintain constant temperature and pressure. So this is correct only. The Nernst equation for the galvanic cell is derived from the Gibbs equation. This is also correct. Both A and B are correct. B is the correct explanation. B is the result of A only. So this both the statements what they provided are correct, and B is the result of A only. So let's see how can we explain this one. In order to explain what is meant by spontaneity in thermodynamics, we have to understand, according to first law of thermodynamics, total energy of isolated system always remains constant. The universe having certain energy, that energy is constant always. Energy neither be lost nor be created, but can be transformed from one form to another form only, right? The first law explains that relationship between the work done by the system and heat absorbed without putting any limitation on the direction of heat flow, right? So this is called what? First law of thermodynamics. Second law of thermodynamics states that no matter what process takes place inside the container, its entropy must increases. Okay, always the reaction is feasible whenever entropy is continuously increasing, then only the reaction is said to be spontaneous. So in this manner, spontaneity is explained in different dimensions. Okay, so here let's go with further spontaneous reaction. How can we calculate Gibbs free energy? Gibbs free energy of the system is equal to, there is a formula, delta H minus T delta S. Delta G denotes what? Gibbs energy change of the system, delta H, enthalpy change of the system, T for what? Temperature, at which temperature we are performing that reaction. And delta S denotes what? Entropy change of the system. Entropy change of the system. Delta G is equal to delta H minus T. Delta H is the formula for Gibbs equation. This is the Gibbs equation. Always this delta G value must be negative, then only the reaction is said to be spontaneous. What they mentioned? Spontaneous process, total entropy change is always greater than zero. That means delta S must be positive. So whenever measure of randomness increases, the reaction is more spontaneous in nature. And another condition is delta G must be less than zero. Less than zero indicates what? Delta G will be negative. For spontaneous reaction, delta G must be negative. This is the second condition what we require. Spontaneous chemical reaction, delta G negative, that exactly mapping what we are saying. And we are maintaining constant temperature and pressure, being it is a standard condition. Let's go with Nernst equation for the galvanic cell is given from Gibbs equation. We have to explain that. In order to explain that one, there is a formula. Delta G is equal to delta G naught plus RT ln K. This is the formula for Gibbs free energy. Delta G value is substituted by minus NFE. Delta G is equal to minus NFE. Again, delta G naught is there, so that minus NFE naught we have to take. Naught denotes what? Standard condition. Fine. And here we have RT. RT remains as such. ln K. ln K means what term? Rate equilibrium constant we are taking. Product by reactant concentration. Product by reactant concentration is taken, right? So if we simplify the same equation, minus NFE naught plus 2.303 RT log product concentration by reactant concentration can be taken. Why? Negative sign is here, positive sign is there. Again, it is converted into 2.303. Why it is converted? Because here ln base E is taken, here log base 10 was taken. So log base E converted into log base 10 by multiplying with 2.303. This is the equation for Nernst equation, right? So this is further exemplified as E is equal to E naught minus 2.303 RT by NF log of product concentration by reactant concentration. This is purely Nernst equation. From where this Nernst equation is derived, the starting equation will be Gibbs free energy equation. Gibbs free energy equation, that is delta G value will be taken. The delta G nothing but minus NFE. We started with this. That's why Nernst equation is the product of Gibbs free energy equation. What they said in the equation number 2. Statement number 2, Nernst equation is the galvanic cell derived from the Gibbs equation. This is also correct. And it is the product of this A. So it is the result of A. What they mentioned in this option number 4 is perfectly correct. For question number 5, option number 4 is the correct answer. Move on to question number 6. Question number 6 is the last question of the session. Which of the following is the correct Schrodinger equation for the wave function psi? So wave function psi, what is the correct representation of Schrodinger wave equation? Schrodinger wave equation is very important, from which is Schrodinger wave equation only all the quantum numbers are derived, and quantum chemistry mainly relies on this Schrodinger wave equation only. It is the most important equation, and it is given by negative h square by 8 pi square m del square psi plus v psi is equal to e psi. So this is the fundamental equation, Schrodinger wave equation. Schrodinger wave equation is derived for hydrogen atom, and it is the fundamental for the all principal quantum number, azimuthal quantum number, magnetic quantum number derived from Schrodinger wave equation only. Right. So let's see what is Schrodinger equation actually. Schrodinger wave equation is just equation, one of the most fundamental equation in the quantum physics. In order to study about quantum mechanics, the Schrodinger wave equation, its a derivation is very important. right? And important topic for JEE. The equation also called a Schrodinger equation, basically deferred differential equation it will be. So here del square values are taken so that it is the differential equation, and is widely used in chemistry and physics to solve the problems based on the atomic structure. The Schrodinger wave equation used to solve the problems based on the atomic structure of the matter. And the equation elaboratedly given like this: dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. This is because three-dimensional representation of matter is taken into the consideration. X coordinate, y coordinate, z coordinate, all taken into the consideration. Let me repeat. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square e minus b psi is equal to 0. This is the equation. But every time writing this extent of lengthy equation is somewhat difficult. That's why we made somewhat shortcut for this one. In order to in order to concise the equation, what we did, the entire dou square side, all three coordinates are represented with del square. Del square is nothing but dou square by x square, dou square by dy square, dou square by dou z square. Everything is represented in a del square. Three-dimensional representation it will be. Psi is the common for all, no? So psi mentioned as del square, psi plus 8 pi square m by h square, it remains as such. E minus b psi is equal to 0. E minus b psi is equal to 0. Or else the same can be represented. E can be taken right hand side. E can be taken right hand side also. E psi you can write like this. So that, so this is the equation what they mentioned in the option number 4. So this is the correct answer. H minus h square by 8 pi square. Whenever this e psi is taken right hand side, the entire left side is becoming negative convention because equation got reversed. Here we wrote 8 pi square m by h square, no? They wrote in reverse form. Just it is the logical representation, but we are not supposed to confuse by this. If denominator is 8 pi square m, so here negative convention will come. If numerator like this, so here positive convention will be there. So that here negative h square by 8 pi square m del square psi plus v psi is equal to e psi. This is the right representation for question number 6. So by this, we completed the entire session, and various dimensions, including physical chemistry, inorganic chemistry, organic chemistry, various parts, various corners of chemistry got explained in a detailed manner. Hopefully, this will be helpful for your entrance or any competitive exam you are seriously preparing for. And I'm sincerely requesting, like the channel, comment, share with the parents, subscribe. Thank you very much for your patient listening. Thank you, one and all.